Pre-calculus 9.2, day 2. We are looking at arithmetic series. We're going to focus on adding up terms in an arithmetic sequence. And there was a mathematician, Carl Gauss, who there was a story about him adding up the first 100 integers, and the teacher was trying to keep him busy and said, hey, well, this should keep him busy for a while. And she about turned around and he said, oh, the answer's this. And she's like, how did you get that? Anyway, and so here we have the sum of the first 100 integers. They're arithmetic because they're going up by a common difference of 1 from term to term to term. And what he did is, notice if I line up the sum of integers in reverse order, and I look at adding, this is a pair, this is a pair, this is a pair, this is a pair, those pairs are always adding up to that same value of 101. This pair, this pair, this pair. And so what you're getting is the sum of, well, we're going to take this one is your first term, this is your last term of A100. So if I take the sum of the first one and the last one, that's that sum that's coming out to 101. And then that there's 100 terms, so there's 100 sets of that 101. The only thing is you've added up the first 100 of terms twice, so we need to divide by 2. So the sum of those first 100 is 100 terms divided by 2, and it's that first term plus the last one. And so we get 50 sets of 101, and it's 5,050. And that's the sum of the first 100 terms of the sum of the first 100 integers is 5,050. And he did it by that lining that up. Well, comes to what it comes down to is that works for any arithmetic sequence. If you want the first n terms, you take the first term, the last term, a sub n, add them up. There will be n terms, but that means you've added them up twice, so divide by 2. And that will give you the sum of the first n terms. So here is the formula for finding a specific number of terms in an arithmetic sequence and adding them up. So this is the series. So anyway, so this is the formula. And so it says here, find the sum of the finite, and we want to always show use of the formula. Yeah, you could put in your calculator, but that's not showing the new learning here. So what we need to figure out is n is the number of terms, and if you count them up, there are 10 terms, and where the first term is 1 and the 10th term is 28. So this formula S sub n being n over 2 a sub 1 plus a sub n, we want the sum of the first 10 terms, meaning n is 10, where the first one term is 1 and the last is 28. And so you get 5 times 29, and S sub 10 is 145. So show it like this, identify the key values that you need to plug in, and use the formula. Well, you might be asked this just a little differently. It says find the 30th partial sum. That just means find the sum of the first 30 terms. And they show you that you have a sequence. Well, we're going to check that it's arithmetic. Remember, it's the common difference is a sub 2 minus a sub 1, so 1 minus a negative 3. This is 4, and you can see these are going up by 4. So it appears to be arithmetic. We're going to assume it's going to continue in the same fashion here. And so I know the common difference is 4, but what I need, and I know a sub 1 is negative 3, but I need the 30th term. And that means we need to use the process from the first day on 9.2. We need to get the general rule. And the rule is a sub n is a sub 1 plus n minus 1 times the common difference. And so I need to find the 30th term, and my first term is a negative 3, n is 30, and my common difference is 4. So a sub 30 is going to be a negative 3 plus 29 times 4, and that comes out to 113, because I need that 30th term. So now I know it. And so the formula, n over 2, the first plus the last term, but we want the sum of the first 30th, so n is 30. My first term is negative 3, and the 30th term, that's your a sub 30, is 113. So we get 15 times 110, and that's 1,650, and that's the sum of your first 30 terms. Example 3, so this is using sigma notation, and probably should have parentheses around that. And so I want the sum, and it's going from k equals 1 to 20. So I am looking for what is the summation of the first 20 terms. So what is it that I need? I need n. Well, n is 20. I need a sub 1, and I need a sub 20. And then I can plug those into the formula to find the sum, as long as it's arithmetic. So we better check out, is this arithmetic? Well, how do we do this is we let k be 1, then we let k be 2, then we let k be 3. Excuse me, that should be enough to check. And then the last term is when k is 20. So I've got a minus 5, a minus 7, a minus 9. So they appear to be going down by 2. And so my common difference is negative 2. And this last term is going to be a negative 43. So that a sub 20th, you do a negative 3 minus 2 times 20, and that comes out to a negative 43. My first term came out to be a negative 5. And so for the sum of 20, remember the formula is S sub n is n over 2 a sub 1 plus a sub n. So 20 is going to be 20 over 2. And then my first term, which we found to be negative 5, plus the last term, which is a negative 43. So you get 10 times a negative 48. And so S sub 20 is a negative 480. So everything kind of shows something a little bit different. And so in this last example, I want the sum of these. Well, if I'm looking at going from term to term to term, it's going down, and it's going down by 7. That common difference, 37 minus 44, is negative 7. 30 minus 37 is negative 7. We're going down by 7. And so I don't know how many terms there are. And again, I always want an algebraic support for it, so we're going to use the rule. And we're going to figure out what term number is 2, which was one of our examples in the previous lesson. So we're going to start with our rule. And that rule is a sub n is a sub 1 plus n minus 1 times my common difference. So a sub n is my first term. And then n minus 1 times my common difference is a negative 7. And so a sub n is 44 minus 7n plus 7, or a sub n is a minus 7n plus 51. That's my general rule. But now this is my nth term, but I need to figure out what n is. So I'm going to plug in 2. As I subtract again, negative 49 was a negative 7n. And n has to always be an integer, so if it doesn't come out to be a positive integer, you know you messed up. So this is a sub 2 is your 7th term. So a sub 7 is 2. But always you need algebraic support, not just guessing and checking or keep on subtracting 7 until you get there and count the terms. You need to have an arithmetic, algebraic support there. All right, so to find the sum, again, it's n over 2, a sub 1 plus a sub n. We know what those two terms were. We know they were 44 and 2, but we didn't know how many terms there were. And now we know that we're finding the sum of the first 7 terms. Again, show use of the formulas, because we found out 2 is the 7th term. And so we get 46, cut it and divide by 2 is 23 times 7 is 161. And we are going to skip example 5. We're not going to need that for this year. And that is the end of the notes.